Hey Wild Ducks! Welcome to our technology podcast. It's my pleasure to introduce the avatar of your host, Jerry Cuomo.
Thank you, RJ. Welcome folks to the Wild Ducks podcast. Our series brings a personal and behind-the-scenes touch to trending technology topics, including AI, cybersecurity, and web technologies. Inspired by Thomas J. Watson Jr.'s Wild Ducks analogy, which describes innovators who challenge conventional thinking, the podcast features conversations with real subject matter experts and creatively fabricated guests using technology. Question: can AI read and understand documents better than humans can? Well, today, we're excited to have Dr. Martin Goodson, founder of Evolution AI, as our guest. Martin and his colleagues created advanced AI models that merge computer vision and natural language processing. This groundbreaking technology achieves highly accurate, human-like data interpretation from any document type, surpassing traditional OCR limitations.
And with that, I am delighted to welcome Martin to the podcast. Welcome, Martin.
Hi.
All right. So let's jump right in. If you don't mind, Martin, the way we like to start off is, can you share with our audience why you love doing the things you do?
I've loved AI since I was about 15 years old.
Okay.
I used to get books from the library about AI instead of studying for my real exams. And as a teenager, I was always programming little AI programs. You know, I was pretty much a nerd. I learned to program when I was about 10 years old.
Okay.
And computers and AI have been a bit of an obsession for most of my life, really. I'm not just interested in artificial intelligence, I'm also interested in animal intelligence and the general question of how objects made of matter can think and learn. Mm-hmm. You know, I was doing research into animal behavior when I was a researcher in Oxford. I also did a lot of work using machine learning models to interpret biological data such as DNA sequence.
And Martin, does the animals studying intelligence, does it include us?
Yeah, absolutely. I mean, we're the pinnacle of animal intelligence, right? So,
okay, great.
Yeah, but this, you know, it's all part of the same field as far as I'm concerned, which is intelligence and, you know, how can matter learn and think. But I just wanted to say that I've always been writing code, analyzing data myself. I've always been pretty hands-on. Mm-hmm. But even since leaving academia, which was about 15 years ago, I've been running machine learning teams in several startups in London. And mostly during that time, I've been interested in the automation of office work most of that time and specializing in natural language processing.
And Martin, did you actually study AI in school, or is that something you picked up along the way?
I picked up. I was really in biology. I was in biochemistry.
Okay.
I was analyzing a lot of biological data. And you know, there's just been a transformation over the last few decades in applying machine learning methods to DNA sequence, for example. So you just had to know about machine learning to do anything.
And over time, since the beginning, let's say you said you were programming at a very young age, what are your favorite tools of the trade? And can you share very quickly how those tools have changed, even up to recently? What are your favorite tools to use for AI?
So now definitely, obviously, everything's going to be in Python and PyTorch. I did used to use R. When I was in academia, I used to use R. I did a lot of statistical analysis and some machine learning using R, which was, you know, great in some ways, but also really, really frustrating. And you know, I was not really a proper programming language, so I'm much more comfortable in a proper programming language like everyone.
Thank you. Great. Yeah, me too. Tell us a little bit about kind of how you kind of came into what you're doing today, and maybe share a little bit about that.
Okay. Well, almost 10 years ago now, I founded an AI company called Evolution AI. Mm-hmm. We specialize in the information extraction from documents. So our clients are typically banks or fintechs who lend money to other businesses. So they need to extract information from a large number of documents in order to run credit models and make lending decisions. You know, maybe they need to read a large number of balance sheets or bank statements. Actually, is a big one for them. It's a really important document for them.
And Martin, are these documents combination of electronic documents, majority electronic, or are there still paper documents around? And what's the proportion? Could you give the audience a sense?
Yeah, it really does depend on. It just depends on industry. It depends on use case. Depends on the type of document. Most bank statements now are going to be PDFs, which are electronic PDFs. Mm-hmm. In the UK, you have a lot of, you know, when you submit your annual reports to the corporate registry, they are typically going to be scanned documents, or very commonly going to be a scanned document. You submit them in paper form, and then they're going to be scanned. So you do get a mixture actually, and actually some of the projects that we do are based on very old documents that might be 10 years old, and typically they can be scanned documents, scanned invoices, for example.
I see. So it's really then that becomes image processing and OCR and things of that nature, correct?
Yeah, I mean, even if it's an electronic PDF, it's really going to be an image processing problem, because trying to parse PDF is actually much harder than trying to parse the pixels. Just looking at the images is normally going to give you better results. So render the PDF and then look at pixels is what we do, and that tends to give the best results.
And what's the trickiest part of a document these days? Is it a table or a handwritten signature or some combination of those sorts of things?
I mean, yeah, it's all difficult. None of it's really been solved. None of it's really been solved. It's really difficult to understand the structure of a document. What is this table? What are the rows? What are the columns? What's the structure of the page? What line? If you're looking at an address, for example, which lines in the document belong to the address? Where does the address start and end? Which line is the company name rather than the address? These are actually really quite challenging problems.
Yeah.
But it's not just that. I say everything's difficult, but also OCR itself, just character recognition, recognizing characters on the page, is not really completely solved.
Mm-hmm. Mm-hmm. Wow. You would think, with all of the progress in AI that these things, but I can see it. I mean, it's almost like a random, like when you look at document from your insurance company versus document from your homeowners association. I mean, everything from the font to where addresses sit. I can only imagine the complexity of the models that you have.
I think, the problem is that there are so many edge cases that it turns out humans are really creative about representing information. So what you think of as the abstract form of a table, you have rows and columns and you have discrete cells. That is just a fiction. When you look at a document in detail closely, you see that people just put data all over the place. So, for example, you might have a line of text which spans multiple columns. Mm-hmm. And a human just reading the document just doesn't even really notice. This doesn't even really register. But this so-called table is not really a table, because you've got lines of text which go across multiple columns. There's no discrete column.
Yes. Yeah, I can
structure.
See.
It's really common.
Yeah. So Martin, can you give us almost like a day in a life, maybe an example? Like things that I'm curious about is how much of this is, on the scale of autonomous to, the AI sitting on your shoulder, watching over what you're doing, like an assistant. Where does this range? Like, so if you can give an example or two and just take us through, a day in a life, maybe working with a client.
Yeah. Okay. So we have, I'll give you an example of quite a long running project that we have with the US firm, Dun & Bradstreet. We're extracting information from around 200,000 pages of scanned images, in this case, which are from the UK Corporate Registry, which is Companies House. We're looking at shareholder information. So who, for all of the 5 million companies in the UK, who did the shares belong to? So these are tables, scanned images, and we need to extract this information. That project is very large scale, 200,000 pages a day, but that has an error rate of almost zero. But that's one end of the spectrum. Mm-hmm. But those tables, they're relatively uniform in structure. We're really dealing with a lot of pages which look generally the same. I mean, like I said, there are always edge cases, but generally they look the same.
And Martin, like from a quality control perspective, do you get for the documents processed exceptions that a human has to go through and say maybe the confidence in this was lower than the confidence of others, so now it gets put on a queue for a person to check, or?
For most projects, yes. For that particular project, there basically aren't any errors, so we don't need to do a lot of human checking. Yeah, that's quite a mature project. The models are really well trained, and also the problem itself is relatively straightforward. But normally, we do like to have a confidence score, and we like to have an exception handling queue. In fact, the confidence score is a bit of a sticking point at the moment, because we're gradually moving over to transformer-based methods. We've been around for a long time. We've been around for almost 10 years. So we've been part of that transition from traditional machine learning, deep learning to large language models and generative AI. Mm-hmm. And this confidence score, we used to have really good confidence scores when we had simple models, and now we don't really. That makes it much more difficult.
Interesting. And you said there was another example, like a more extreme example.
Yeah, so we do lots of work in finance, business finance. So lots of our customers are providing credit to other businesses, and so they need to do a lot of due diligence, credit scoring, and so on. They're going to do a lot of document processing in order to build their risk models, for example. They're typically looking at bank statements and financial statements. Both of these problems are quite difficult. Both of these documents are quite difficult to understand. Bank statements. We have a really good model for bank statements. It's very strong, and it's been very successful and popular. So but it still does have. There are still some errors, and there's still an exception handling queue, like you say, with confidence scoring and so on.
Interesting. And Martin, do you actually do math? Like, do you check the math in the documents, or if it's a finite? Wow. Okay.
Yeah, we do. It's important to do that. We do quite a lot of checking of the documents. You can't really go into too much detail because these documents are often subject to fraud. So you need to check various things to make sure nothing dodgy is going on.
Martin, so we're coming down to the last set of questions. Can you talk a little bit about the future, including, how these models perform, and where do you see them going forward?
Okay, so how do these models perform is quite an easy question to answer, because I would say not very well. So
are there benchmarks?
Yeah. So there are some really good benchmarks. So DocVQA is a classic benchmark to use when you're looking at documents. And there are some smaller benchmarks as well, like Deepform and Kleister Charity. So these are really good for what we're interested in, which is document analysis. So there are some other OCR-based benchmarks, like OCR Bench, for example, or you might see TextVQA. These are for text, and they are for OCR, but they tend to be for scene text, which is where you have, like a billboard or a sign on the side of the road, which is subtly different to what we're interested in, because documents tend to have very small text. This is kind of getting into the technical weeds here, but documents have very small text compared to scene text problems. So this is really hard because you need high resolution images. In documents, you've got these small fonts with lots of high frequency information. If you convert that to a low resolution image, you've lost a lot of information and you'll start to see lots of errors. This is really well established. So, you have to be a bit careful on the benchmarks.
So maybe take your crystal ball out and let's wrap it up with where this is going.
Well, like I said, there are still quite a lot of errors. The performance is not great for things like OCR. So, for instance, if you're trying to extract information from a document using, one of the products from Anthropic or OpenAI, you will see in each document, you're probably going to see some kind of error, like digits have been swapped over, or even whole rows have been swapped over. Or in the case of a financial statement, you might see a whole line item which has been completely hallucinated. There are more errors than you might think for this problem. Like I said, this high resolution document problem is quite difficult. So hopefully we'll see some improvements there. But what I think is really exciting now is that you've now got some open source models like Intern VL. Do you know if you came across that?
IBM has Granite. So there is some really good activity going on with Hugging Face and Meta and many. Yes, I agree.
Yeah, on Hugging Face, there's a Hugging Face space for QuenVL, I think, which is supposed to be superior to GPT-4 on the benchmarks. You've got Sonnet 3.5 released by Anthropic, not open source, but it's still another model which is very competitive on these kind of benchmarks. So it's very exciting, actually. It was looking for a while like OpenAI was the only game in town, but things are changing, including in the open source world, and I think was unexpected. So we're really excited about that.
I'm so excited about that too. So Martin, thank you so much for joining us on the podcast today. It was a pleasure.
Thanks, Jerry. See you soon.
Okay, that's a wrap on this discussion between Jerry and Martin. Well, what do you think? Can Martin's AI understand documents better than a human? After listening, I'd have to say perhaps yes. Also, check out the episode description for additional reference material. Speaking about AI, did you hear Jerry has a new book out called Think Artificial Intelligence? Jerry is donating royalties to the St. Jude Children's Research Hospital. So, buying is really a form of donating. Once again, we'd like to thank Martin, and we'd also like to thank you all for watching. On behalf of Jerry Cuomo, IBM Fellow, and Wild Duck, see you again soon. Bye.